We're going to continue on with our discussion of the basic concepts here with Python. Take just a minute though and go back and review a little bit of what we covered in the last couple of sections where we talked about numbers and strings. Just a brief recap here. When we're talking about numbers in Python, there's two types of numbers. There are the integers or whole numbers, and then there are the floating point numbers, which are the ones with decimal points by them. We also talked about the concept of a variable. Setting up a variable is a name that points to some specific location in the memory that holds that data. We'll elaborate a little bit on that here later in today's lesson, or the next chapter or section here. These are examples over here of assigning a value to a variable. We also talked about how to do a little bit of output using the print function. We can do some basic output displaying actual values of expressions or printing the value that's held in a variable. We then looked at arithmetic operators, the basic math type things that you'll need to be able to do with the numbers. We also talked about some particular words that are not open for you to use in terms of your own variable names, such as return and while and if and those types of things that we call reserved words. We also introduced a few mathematical functions, absolute value, integer, and rounding. Of course, the big clue there is that there's a lot of other ones available to you as well. We also covered the fact that Python is case sensitive, so a variable named lowercase price is going to be different than uppercase price. We talked a little bit about an idea called augmented assignments, which really just means some little shorthand notation we can use to increment or decrement or other values on operations that we can do. Like I said, just a shorthand notation. And lastly, the different kinds of errors that we might run into in a sense of syntax errors where you misspelled or mistyped things versus some exception errors where you just try to do something that wasn't legitimate, like divide by 0, and then logic errors, which are just your mistake of creating an expression that just doesn't make sense. The second section we talked about strings, the idea that a string is a different kind of variable that holds characters, and we define those characters within a set of quotation marks, whether they be double quotes or single quotes, doesn't really matter. And then we talked about targeting certain positional points within a string by their index position, S3 being H, and always remembering that we start with 0. And we talked a little bit about taking a slice of a string or creating a substring, if you will. And again, the syntax for that is the square brackets with the range separated by the colon in there. Introduce the idea of moving from the right side to the left direction of the string by using the negative value, and also an idea of either the beginning or the end, or neither, which would give you the whole thing. We introduced some functions and methods. Again, this is just a few of the ones that you can utilize. Length, finding a specific occurrence of a substring within the whole string, converting from upper to lowercase, counting the number of occurrences, converting to title notation, and stripping some things off out of a string. Possibly some new words, concatenation here, the ability to concatenate a couple of strings together or to repeat them. And we looked at the beginnings of a way to input information into your program, the most simple of which was simply to prompt some data from the operator using the input statement and assign that answer to a variable. And also we looked at how to introduce comments into your code so that it would be more readable as you went along with the pound sign. And then the last thing here was to do a line continuation with the backslash character. So based off all that, let's move on and expand some of those concepts and talk a little bit about output. If you recall, we talked about programming in the sense of input, processing, and output. You have to get the data into it before you can process it, and when you're done, you need to output that some way that'll be useful. Now, we've already looked at using print as one way of getting information out, and this is the basic statement that we worked with last time. And the standard separator here is a space character when you use the comma to separate your values. We introduce a new little argument we can use with a print statement here called the separator argument. We can actually specify how we want those elements put out, with what kind of an argument do we want between them. So if we just specified the separator to be star star and did a print on hello world, we would get star star occurring between hello and between world. If we make it a null value or null value, then it doesn't print anything in between there. Or we could set the separator to be 2 or 3 different spaces to kind of stretch things out a little bit. Now this is particularly useful if you are exporting data. Let's say you take and open a file full of data, you read it in, you use your Python code to process it, and then you want to write it back out to another file that could be consumed by another program, let's say by an Excel spreadsheet, for instance. One of the more common formats for doing that type of a thing is have a comma separated value, or a CSV file. So in that case, you could set your separator up to be a comma, and then you would output that, and all of the elements would be separated with a comma, and then you'd be able to read it in to an Excel file. There's another optional argument called end. This just basically sets up how it handles the end of the line. Normal convention is to do a new line operation when you just do the print statement. However, you can change it with the end argument. So you could change it to just be a blank space. Here they've given an example. So you totally miss the new line occurring here, even though there's 2 print statements. Over here they've totally eliminated it and just made it a null value, so that they actually run together even though there's 2 separate print statements. Another thing is the escape sequence. These are special characters that you can put inside of a string that will cause certain actions to occur. The 2 more common ones are the tab and the new line. So you can do a \T for a tab, or a \N to insert new lines where you need them. The \N, this is very similar to when we did the break, the BR statement in HTML, where we wanted to break to a new line. Basically the same kind of a thing. But the escape sequence, or the escape character, the \, is quite useful for escaping other special characters that we might want to have printed in our actual output, like quotes and some things like that. Here's an example of using escape sequences. We have a string of numbers printed out, kind of give us a helpful index on the positions here to kind of keep track of what's going on. Then we do a print statement, A, B, and C, but we use \T in here to insert a tab character between the 3 letters. Default on a tab is, I believe, 8 characters, so we get A all the way to B and then all the way out here to C. We can modify that output if we want. We can tweak the tabs to be whatever we want using this modifier of .expand tabs. Here they've set it up to be 5. Re-executed the same statement, and this time you can see the tabs are not as long. They're much shorter. There are only 5 characters between. And then this last one is an example of inserting some tabs. Here's a new line, so you'll get a line break occurring there. Another tab. and then they've set up the tabs to stretch them out a little bit so that they're actually 11 instead of the usual 8 or 5. Notice it's not spaces between the variables, it's the actual positional index. So 11 is here, and that's where it starts. All right, the backslash, as I mentioned, can be used to display special characters that would normally be interpreted by the Python editor. So the most common use of this, again, is to print out double quotes where you want them instead of having them being interpreted, or a backslash character. If you need a backslash character in your output, you have to precede it with another backslash character. A couple of new modifiers we're going to look at. Justification of your output. You can left justify, right justify, and center your output. The argument here determines the length, or I should say the width, of the field that you're going to use. So here's an example. Again, we're printing out a long string of numbers to get an idea of where we're at positionally. Then we're going to print the text rank. We're going to modify it by making it left justified and making the field width 5 characters long. So here's the field width. Then we're going to do player, left justify, 20. And finally, number of home runs are right justified, and they're 3. So that'll come back from here. Notice separator has been set up to be null, so there's no separator between them. This helps us control the layout in a table kind of a thing a little better. Then we actually print the data. So we're going to print our ranking 1, 2, and 3. This is going to be centered within our 5-character width. You can see that that's what happened down here. Then the text of the baseball players left justified within the 20-character field. And finally, the number of home runs right justified, again, 3 characters. So I think you can see how that works easily enough. Just to keep things interesting here, there's multiple ways of doing things in Python or any programming language. And here we're going to give an example of the idea of formatting something with the statement of format and contrast that to just, you'll see how here as we go along. This particular syntax has the modifiers inside the curly braces. So we're going to start off setting up our modifier here between the quotes. Then we're going to do the dot format, and then the argument that's going to be coming into the whole print statement, which is what's going to get modified, is what's in string 1. So str1 is the string, and w is the field width. So these are actually equivalent, these statements. It doesn't make a lot of sense until you actually see it in operation here. Another example, setting up the format statement. This is done on a number instead of a string. We can do certain actions on numbers and certain actions on strings. And here's an example. Again, we'll print out a big long list of numbers to help see what's going on here. So the easiest way to look at this is start over here and look at what exactly are we doing here. This is the text that we're going to format. And this is how we're going to format it. So we're going to take 3 elements or items here, the text, rank, player, and home runs, and we're going to format it according to this. We're going to set it up so that the 0 element has 5 field width and it's a string. This one is the first element number 1. It's left justified. Okay, and this was center justified. I skipped over that. The arrow up means center justified. This means left justified, and this means right justified. Okay, now take a look at this and you can see it's just the same kind of a formatting, but it's going on in a different kind of a syntax. And here's an example of the same thing. Instead of strings, we're doing that kind of formatting on numbers. So up here, we're using the 0 element, and it's going to be in an integer, a decimal format. So you can see the outcome here. It's an integer. Here we have, the separator going on. Still the 10 from 0 to 10. We're getting all of the elements, but this time we're adding a comma as a thousandth separator. Here's 0.2 in a floating point format. Okay, this is a rounding occurring here by nature of the fact that we're dropping it back to only 2 decimal points. That's kind of an automatic rounding. Here we have rounding with the thousand separator. Rounding and separators and decimal points. Using percentages, you begin to get the idea here. These are the kind of things that take a little bit of thought to get set up on how you want to actually do your output. So the curly brackets, here's an example of that. They don't have to be done explicitly within the print statement. They can actually be built and constructed in the string itself. And then you print the string, and then it automatically goes through that formatting process itself. So here's an example of that, where we set up the string inside of a variable. Well, this one's inside a variable, but we set up the string in a quote so that it includes the text and the curly bracket formatting. So the area of, starting at the 0th element in a string format, is subelement 1 with a separator of comma in a decimal format, square miles. And this is the data that we're actually formatting and processing. So that prints right here. The area of Texas is 268,820 square miles. And here's the same thing, more or less, but where the actual text, including the formatting, is assigned to a string, and then you just print the string with the format and the data. Notice they're also doing a little bit of math in there as well. And that's the end of that section. You can see that this starts to get a little complicated, and when you go to do your output, you want it to look nice, and just be aware that there's a lot of opportunities in there to tweak the way that the text gets output or the numbers get output into your report or your file or whatever it is that you're trying to generate here. All right, we're going to move on to our next section here, which is on lists, tuples, and files. This is an extension of what we started learning here, but this adds some additional objects to the capabilities and things that you can do. So let's talk a little bit about the list object. Now, a list is simply a sequence of objects. Objects can be any type. They can be text, they can be numbers, or they could even be other lists. But to start off with here, we'll just take a look at a simple idea of a list and the syntax that we need to construct it. So we're going to set up a list called team using the square brackets, and then we're just manually providing it with the elements that go into the list. So we've got 2 strings plus a numeric variable here. Here's one that is nothing but numbers, 4 different numbers. and here's one that is just words, just strings. So they can be mixed or they can be all the same. Now, as you might expect, just like we had a lot of different ways to manipulate and do operations on numbers and strings, we can do similar things on lists. So we can describe the length of a list. Back here, you remember we had in words, there were 2 of them. So if we do the length of words, it tells us how many elements or number of items that are in the list. We can do some mathematical things like calculate the max, find the max value of all of the items that are in the numbers list that happen to be 10. The minimum, sum, we can actually sum up all the values that were included in that list. We can count the number of occurrences of a particular object. So here's an example of counting how many 5s there were in the numbers list. How many 5s were there? 1, 2. We can also return the positional index for the first occurrence of an object. Where, at what positional value did the number 4 first appear? Well, it appeared 0, 1, 2. And then there's the result. You can also reverse things. Saves you a little bit of coding time to be able to do that automatically. So take the list of words and reverse it. Here's some more. We can zero out a list. We can just clear it out using the clear modifier. Or we can append items to our list. Here's an example of appending the number 7 to our list. Sticks it in at the end. Now this one's very similar, but it's a tad bit different. The idea of extending it, okay, inserts multiple items into the end of the list. So append generally means one object. Extend can be multiple objects. We can delete an item from a list. Here's an example of using the negative modifier. Remember, when you use the negative, it means start at the right end and move to the left. So this would remove that third element that was out there. I think that was the name of the field, baseball field. We can also remove certain items out of a list. So we can remove the first occurrence of the number 5 from the list. Or we can insert. We can take the one what originally was numbers, and we can insert at position number 1 a text string of wink. I think this should have been words, not numbers. Must be a typo there. And then we can also use the concatenation and repetition operators as well on lists. So let's take a look at an actual example here. Program that requests 5 grades as input displays the average after dropping the 2 lowest grades. So we're going to set it up. We're going to create an empty list. And we're going to, well, I guess it's, create an empty list. And then we're going to set up a variable called num. And we're going to do an input statement from the user. Input the first grade. We want it to be in a floating format. So this is the statement we would use. And we're going to take our list of grades and we're going to append to it the value that we just took in of num. Then we're going to repeat that for the second, the third, the fourth, and the 5th grade, each time appending that value to our list of grades. Once we've got all 5 of our grades in there, we can set up a new variable called minimum grade, and using our function on called min on the list grades, that will return the first of the minimum grades. Then we'll remove that, and we'll then repeat this operation because we wanted to drop the two lowest grades. It's the next minimum grade, and we'll remove it again. And finally, with what's left in there, we'll calculate an average based on the sum of the grades divided by, in this case, the length of grades would tell you how many elements are left in there. And so the result of that does actually equal the average. And finally, we print average grade, and we do a little formatting. We want just the first element. We're going to do 2 decimal places and a floating point, and we'll format that. So this is what it would look like when we ran the program. Enter the grade 89, 77, 82, 95, 81. In our code, we want to be able to throw out the two lowest ones, so we should be getting rid of the 77 and the 81, which leaves these three behind. Add those up, divide by 3, and you'll get the average grade. Now, if you recall, when we were talking about strings, we had the ability to create a substring out of a string by doing something called slicing it, taking a slice out of it. And we can do the same thing with list. It's got the same syntax using the colon notation. So we do the same exact thing where we can specify the positional values of the index one, beginning and the end. We can omit the whole thing. We can specify only the beginning, letting it roll out, or the beginning point, letting it roll all the way to the end, or specify the beginning up to some point. So same syntax, only the thing is we're operating on a list instead of an actual string. So here's a list, list 1. We have 1, 2, 3, 4, 5, 6 elements in here. So if we specify what are the elements occupying this range, those would be the values of B and C. Again, using the negative notation, it starts from the right, moving to the left. So we're going to come back 4, 1, 2, 3, 4, and go for a total of 2. But let's see, that's negative 2. C and D. So then we have from the beginning out to position 4. You have to work through these things because they're not super intuitive. You just have to be careful with them. Test your code. It's the only way you're going to figure out how this stuff works. Test your code, put in print statements so you can see exactly what you're getting, and because it'll mess you up a little bit. This business of counting with zeros most of the time, not all the time. Okay, no parameters, it prints the whole thing. Delete these elements, so it takes out the B and the C, and so on. Don't need to go through all these. You can take a look at them on your own, and this is right out of the book. A couple of other methods, the split and the join. Just do exactly what you would think. Takes a single string and splits it into a list of substrings, or it takes a list of strings and joins them into one string. And these are just the opposite of each other. Here's an example. Split based on where the comma is here. I'll split A, B, and C out. If you define the split, which one to look for. If you leave it as a null operator, it assumes that it's looking for the null or the new line or whatever the separator is. Just kind of like a default sort of a thing. So here's a line. This is a list of words. 1, 2, 3, 4, 5, 6 words. To be or not to be. If we print and leave this blank, put in dot join the line, it will join all of these together and print just like that. Notice that it's giving us the space in between the different elements, because that's what we defined right here. On the flip side of that, if we do the same thing with Rice Krispies here, snap, crackle, and pop, instead of the space, we put in a comma space, do the same thing, then the output is generated as snap, comma space, crackle, comma space, pop. All right, well, inputting information from the keyboard is certainly one way of getting it in, but a lot of times when we're coding, we're interested in being able to read in data files. So a data file, most often in our line of effort here through this course, will be a text file. Simple ASCII text file that has data in it, no formatting. In other words, you can't really read in a Microsoft Word file because it's got a lot of extraneous formatting and you wouldn't really understand the format. So we're going to stick with text files, and we know that Python then can access those values. Here's an example. There's 3 lines of code that will open a text file, read the whole thing in, and close it. And we'll explore some of the syntax later, but for right now, just recognize it for what it is and be ready and willing to use it. Very simple. We're declaring a variable called inFile, and we're going to open a text file that's out on the operating system somewhere called data.txt, and we're going to open it in read mode. And we're going to set up a list called listName, and we're going to use this function to strip off the new lines from each line, and we're going to do that as we read everything in for every single line in the file. And then we close out our file access. Note that when we're doing file operations, we always have to open a file and close the file. So that's what we do. We open a file, we strip the new line characters, and we read it all in to our list. Here's another example. Let's suppose that all of these are going to be numbers instead of text. Let me back up here real quick. So we had data.txt and read, and we're doing line rstrip. Here we're doing the same first line. We're opening data.txt and read, but instead of doing the rstrip, we're doing an eval. Remember back where we talked about numbers and doing an eval? That converts it to a text number. It sounds like an oxymoron, but a number in it that's in a text file, it's a number. It's going to come in as a string unless you convert it. So this is a conversion routine, basically. It takes text files and converts them to numbers so that you can manipulate them. Okay, new word, something called a tuple. This is a little bit different concept. A tuple is like a list in that it is an ordered sequence of items, but there's a distinct difference here in that a tuple cannot be modified in place. So there's no way to append or extend or insert data into it. So you cannot directly manipulate these things. And this introduces another word that we'll get to momentarily here. But for right now, remember that basic list functions and methods still apply to a tuple. You can still access them the same way with the indices. You can still slice them and concatenate them and do some repetition on them. But they're written a little bit differently. They're written as comma-separated sequences that are being closed in parentheses, or even without the parentheses. So here's an example of a tuple. Just by setting this up as t equal 5, 7, 6, 2. That's a tuple. It's a separated elements. Could have the parens on the outside, but this one doesn't. You can print it. You can do basic manipulations to it. Notice when you print it, you get these parens around it. That's a clue that it's a tuple. But if you print the length of it, it'll tell you that there were 4 elements in here. If you ask what the max was, you'll get the max, which was the greatest number of any of the elements, the min, the sum just adds them all up. If you print the 0th element, you get the 0th element, and starting from the right, moving back, same basic manipulations that you're used to seeing. But here's an interesting thing that you can do with tuples. You can actually swap the values of two different variables. If you look at this, you have x equals 5 and y equals 6. And then this interesting statement here where we're reversing the values. X comma y equal to y comma x. So what that's really saying is, remember, we evaluate from right to left. So it's saying take the value that's in x, stuff it in y. Take the value that's in y and stuff it in x. Then print the two values out, and you'll notice that they've been reversed. Kind of an interesting little twist. Another thing you can do is nest these things. So you can have items that are lists that are composed of other lists or tuples. So if you consider a list of tuples called L, then L sub 0 is the first one, and L sub 0 would be the first item that was in the first tuple. So this will start to stretch your brain a little bit. You just have to pay attention to what's going on with the indices here. So again, the reverse notation, L with a -1 is the last tuple, and that would be the last item in the last tuple. So here we have an example of nested lists. The program manipulates 4 tuples where each tuple is given a name and a 2010 population. So we set up our tuple. Here are the 4 elements, actually 4 tuples, each of them having 2 elements. And then you can just do a print statement, and you can represent this by saying regions, the first, not the first, sub-element number 1, and the 0th element. So this is 0, this is 1, and then the 0th element would be Midwest, and that's what prints out down here. Was, and then regions, again referencing the tuple. This element, again Midwest, and this 66.9, that's what prints out down here. So you can see how this works, and here's an example of using the format. So you can mix these things together and come up with all kinds of different ways of doing things. That's why there's normally not only one right way of doing things when you're writing code. Just to consolidate that thought process on the tuples a little bit, we have a concept called immutable and mutable objects. Now the word mutable, it means something that is subject to change, constantly changing. For instance, the weather is a very mutable object. So think about this. An object is an entity, and it holds data. And we can do operations and use methods that can manipulate that data. So when we create a variable with an assignment statement, the value that's on the right side becomes an object somewhere out there in memory. And the variable simply points to that object. So when we alter a list, we're actually changing where the object in the memory location. We're not changing the list, we're changing the object in the memory location. So there's a little bit of a contrast here. When the value of a variable is a number, right? And when that value gets changed, Python designates a new memory location to hold the value. And that variable references the new object. Simplest way is to see an example of this. But another way of saying it is that lists you can change in place. Numbers, strings, and tuples you cannot. So, objects that change in place are mutable, like the weather. They can change all the time. But objects that cannot be changed are called immutable objects. So let's look at how Python allocates memory when it goes through a program. If we set up this list with these two elements, when it executes that, this is what's in memory for L. If we set up a numeric variable and we assign it the value of 2, and it's going to be pointing to the value of 2. A string with the value of Python, it's going to be pointing to there. And a tuple with these 3 elements in it is going to be looking like that after these first 4 lines of code have been executed. Now let's continue executing some additional code. We're going to take our list and we're going to append the value of 7 to it. So now in memory it looks like this. We're going to increment the value in n. So n is now going to point here. If we do an uppercase on the value in string, it's going to do that. And if we set the tuple equal to the element from 1 on out, it's going to be represented by B and C. So look at this and see if this makes some sense here. If we have list 1 and it's equal to the 2 characters A and B, this is a mutable object. If we set up a new list 2 and we set it equal to list 1, list 2 is going to point to the exact same memory location as list 1. Ooh, wait a minute. 2 different things. List 1, list 2, they're equal because they're pointing to the same memory location. So if we take list 2 and we change subelement 1 of that list to a C, which would have been a B, and we change that to a C, and then we print not list 2 but list 1, aha. So there's pointing to some location in memory, and the operations that we do on list 2 also affect list 1 because lists are mutable. They're subject to change. Now if we contrast that, same thing. We set up the same list, but this time we say that list 2 is equal to a new object called list of list 1, a new list object. Now all of a sudden list 2 is pointing to a different location in memory, and if we do that same operation on it, that changes the value only of list 2. So if we print list 1, we can see that it's not been altered. So these are things that you just have to get used to thinking through as you start working on developing your code. We talked about how to index and delete, and we talked about slicing and things that might be out of bounds. Basically, you can't go out of bounds when you're indexing as far as lists and tuple are concerned. You can, however, slice it, and this is kind of an odd, exceptional sort of a thing. Here's a list. Here's your 5 elements. If you try and print an element that's outside of bounds, you can't. No, can't do that. Same thing with trying to delete one or using some range that doesn't make sense. The odd thing that does work is that you can slice something that begins out of bounds as long as it ends somewhere in bounds. So this is kind of a peculiar behavior, but it does work. So if you start from the 10th element, even though there is no such thing, and come backwards all 10 elements, you'll still get the full 5 that are in there. It's kind of an unusual scenario, but you shouldn't run into that very often. So that concludes that section. A lot more things to think about, more challenging ideas of how you're going to do input, read in data, process that data, and output it in a format that's nice for human consumption if it's a report that you have to write for your boss, or if it's output to a file that's going to be consumed by another application, you got to make sure you get it into the right format. So there's all kinds of different considerations that you have to think about when you're doing input processing and output.